The next one. Okay, so today we're going to be learning about the constant rate of change. So we might have talked about yesterday the definition of constant rate of change. It is the relationship describing one quantity, how one quantity changes in relation to the other. So yesterday we talked about a computer programmer charges customers per line of code written. Fill in the blanks with the amount of change between the consecutive numbers. Now, before we started filling in those little boxes, I had you label something. What did I ask you to label for? I had you label something on the side. Right over here. The X and the Y. So which one is the X?
Lines of the top one.
The lines of code. And then the Y is the cost. And then you had to calculate the difference as the lines of code change from 50 to 100, 100 to 150, and 150 to 200. How are they changing?
Plus 50.
Plus 50. So you should have plus 50.
Oh, yeah. Sorry.
On the change on the Y, what is it changing by?
1,000.
By adding 1,000, right? Each time.
Oh, I got the wrong thing.
Okay, and then on the bottom, it tells us to label the diagram below with the terms in changes in lines. So these are the labels we're going to be using. Change in dollars and constant rate of change. So this first one right here is asking us about the change in the dollars. So we're going to go ahead and write that, the change in dollars. And the second one is talking about the change in the lines. Now, we talked about yesterday as well that we call this change, we call it, does anybody remember? Delta Y over delta X, which is the change in Y. And the delta is just, it means change, how it's changing. So how Y changes over how the X changes. When you give me an answer that has related to the constant rate of change, it needs to be a Y over your X. It's going to be in fraction form. So on the bottom, this is the constant rate of change. So the constant rate of change is $20 per line of programming code. Now let's go to the next page. Okay, number one. Okay, you're going to go ahead and read number one on your own. So it's asking us to find the constant rate of change using this table right here. So just like the table that we used on the other page, the first thing I need for you to do is label your X and your Y. So which one of these represents your X? The number. So go ahead and label it. Okay, X. And which one's the Y?
Money.
The money. And it already did the calculation for us. It told us that the change on the X was a plus 5 and the change on the Y was a plus 40. And they already did the work for us on the bottom, right? So all I'm going to do is I'm going to label that the change in money is my delta what? The delta Y. Remember the Y goes on the top. And the change in cars is your delta X. And if I look here, my Y was the money and the X was the number or the cars. So they already did the work for us. They wrote 40 over 5. Now they changed it to 8 over 1. Can anybody tell me why? They simplified it, and also when you're talking about constant rate of change, you need to write it as a unit rate. So you want to find out how much it is for 1x, right? So my x is 1. what would my y value be? Okay, whatever your x may be. If they're talking about minutes, if they're talking about miles, if they're talking about coupons, whatever. Doesn't matter. 1x is what you're trying to find out for your constant rate of change. So they answered it in a sentence. So the number of dollars earned increased by $8 for every car washed. Let's look at letter A. We're going to kind of do this together. And then you're going to work with your partner a little bit. So the first thing I'm going to do is I'm going to label my what? X and Y. So which one is my X?
The time.
The time. So I'm going to write time is X, so label it. And my distance is Y. The next thing you're going to do is you're going to find out what is a change in your X and what is a change in your Y. And I'm going to give you about a minute. I want you to talk with your partner and find out what are those changes and label them. All right, so what do we find out is the pattern between the X? So 30 to 60, 60 to 90, 90 to 120. Joe?
Plus 30.
Plus 30. And then what was the pattern for the Y?
290.
So adding 290, do we agree, class?
Yes.
Now, I'm not done. This is just the information I need to calculate before I get to my answer. In order for me to calculate my answer, I have to do my delta, what? Y over your delta X. All right, go ahead. What would be my delta Y? What was our delta Y?
290.
And what is our delta X?
30.
30. Now, is that my final answer?
No.
Why is it not correct?
You can simplify.
Okay, I can simplify. What else is wrong with it? What is
Improper
this?
fraction.
Okay, it's not a fraction. It's a ratio. So I will be careful, okay? So it's okay for it to be improper because it's your y over your x, and typically your y will be more than your x. Not always, but most of the time. However, we're talking about two different things, so it's okay for them to be one greater than the other. What I do want you to know is we talked about it up here. What's wrong with it? My x has to be a what?
Unit rate.
A unit rate, which makes it, my x has to be a 1. So I have to figure out a way to make my x a 1. How would I do that? Okay, let's slow down. I can start by crossing out the zeros, and that leaves me 29 and 3, but my x is still not a 1. Well, 3 doesn't go into 29 evenly, but it does go into 29.
Yes.
Okay, so 3 times 9 is 27. So I want to see you doing the math too. So we're going to divide it. And that's going to give me a 2. What happens if I have a remainder? I add a what?
Decimal.
Decimal. Move your decimal up. Add a 0. Bring the 0 down. 3 goes into 20. 6 times. 6 times 3 is 18. Subtract. Get a 2. What do we see happening?
Repeating.
It's going to repeat. So I'm going to draw my little bar. Above my 6. Now I'm going to write this. So this means that I have 9.6 repeating.
Over 1.
Over 1. Very good. But I'm missing one very important detail that I need to add to my answer. Okay, I'm almost done, but I'm missing something.
Time.
What am I missing?
Multiplication. Times.
Time? Like distance?
The changes.
Dollars.
Are we talking about dollars?
No, we're talking
Time and the distance.
The labels, very good. And it's not just time and distance, it's being specific. What kind of time, what kind of distance?
Minutes.
So the 9.6 repeating represents what?
Minutes.
Okay, 9.6 minutes.
And then
Does it?
yes.
You all agree?
Yes.
Miles, yes. And in one, what?
This minutes.
1 minute. And this is talking about a flight, right? So that's telling me how fast the airplane's going. 9.6 miles in 1 minute. Now on my problem it says determine the approximate approximate constant rate of change? Okay, so can I round this? Can I give you an approximate answer? What would that be close to?
10.
10. So we would say 10 miles in 1 minute if we were going to just round it up. But we got the exact answer, so we're going to leave it like that. All right, let's look at letter B. Letter B, the table shows the number of students that buses can transport. Use the table to determine the constant rate of change in students per bus. So I want you to label your X and your Y and find the rate of change for your X and your Y. You got 1 minute. All right, so let's look at B. What was our X and what was our Y?
X is numbers and then the Y.
Well, they're both numbers.
X is
Is
number
the-
of
X is 72.
X is the buses and Y is the
number of
students. Okay, and then the change on the buses plus 1. And the change in the students plus 72.
Right.
So what is my delta Y over my delta X? 72 over. Okay, it stays the same because it's already a unit rate. I already it has a 1 as a denominator or at the bottom. So, but I'm missing something. What am I missing? Buses and students. So which one? 72 what?
buses.
Students. It's the Y, the students. In one bus. And this is our answer. 72 students in one bus. That means you have about 3 kids per seat, right? So they must be a bunch of kindergartners. Poor bus driver, right? All right, moving on to the next one.